Neither.
So I'm going to stand right in the middle. My name is Greg Duplessis. I'm, along with Lee Stein, the other kind of co-creator of the meetup. And a couple of things I want to chat with you about, but a little bit about me. I'm 20 years this year in the data storage industry. So, started way back when the only guy you talked to was the storage guy, was the guy with the ponytail in the back of the shop. Now, now data's strategic to everyone, of course. So, been a lot of changes. I now own a company that puts on networking events for mainly storage executives, CEOs, and VPs, called the Exec Event. So you may see that in some of your emails or logos and things like that. But a couple of things I wanted to chat with you about. On your chair, you may have seen that the next generation solid state storage conference is coming up in, it's actually the first solid state storage conference coming up in August, and we are co-located with the Flash Memory Summit. So the Flash Memory Summit, if you've been to that, some of you I'm sure have been, is a very technical summit. It's geared towards technology people and bits and bytes, etc. The exec event version of that we're partnering with Flash Memory Summit is more on the business, the marketing, the messaging side of the vendors that make the stuff, and then sell it to end users like many of you. So the point of this sheet on your chair is there's a great opportunity for SSD end users to actually participate in this and actually have a voice with kind of the who's who of people who make solid state storage technology. To get in a room with them, to actually converse with them, to have dialogue with them, to network with them, This sport. So there's an opportunity, and for some of you this makes sense, for some of you it does not. But we're going to have 50 to 75 pre-qualified end users to actually participate in a room like this with actual vendors, with CEOs, with VPs of technology companies that give you an opportunity to really converse with them, and really say what you like and what you don't like, and the things that you like to see on roadmaps and all of that. So I think it's a wonderful opportunity. We'll have the vendor technology guys. You'll have certainly your peers will be there. It's free to qualified end users to participate in that. And we're going to basically select a bunch of you folks. You're the very first group that this has actually been presented to. So I think it's a really good opportunity if it fits you, fits your model. Remember that the Solid State Storage Conference is co-located. It is not the flash memory storage. So it's actually two different things. We're in the same building at the same time, but I'm business related, they're technical related. Right? So it's really two different things. If you're interested in the kind of the business aspects of solid state storage, then by all means let me know. So a couple ones here. Yes, I will get to that. First, yes, so there's an opportunity to, you can, if you want, fill out your name on the back of this and just give it to me, or anyone here. My email address is up here. Feel free to use that and send me a note. I apologize for not actually having that on this. I don't know why it wasn't. And then just a couple other quick notes, and we'll jump right into our next speaker. Our next meetup, a large meetup of this group. That doesn't mean there won't be smaller ones. We've had that question already. But the next large one will be Monday, August 12th. And it will be here somewhere. I'm not quite sure, possibly. I don't know who's going to be hosting it yet, but we'll be working on it. So there could be smaller ones in between. And I guess I will stop talking at that point. Does anyone have any questions regarding the solid state storage conference? Does anyone care? Yes. So a couple other one other quick announcement, and we'll get on with Mr. Crump. Our friends at Sky Air, since they're hosting here, and they were kind enough to feed us So with that, I will like to introduce Mr. George Crump, who is the Chief Steward of Storage Switzerland. He's actually one of the world. Stand over there, George. Maybe it was him that did that before, not me. And anyway, is very well known, very well respected, writes a lot, speaks a lot all over the world. So we're very lucky to have Mr. George Crump here tell us a little bit about the storage world, the SSD world. And I would imagine a little bit less technical than the previous.
Yeah. Like God's talking. Can we turn that down?
God. Yes.
Okay. All right.
I can turn that down.
Okay. I think the Oakland A's can hear me. Wow. Are you going to put my presentation up too?
Yeah.
Okay.
Hey, Jackson.
I can wait. Everybody okay? Get enough pizza? Oh, I forgot my clicker. Throw it to me so I don't come close to the thing.
You're on.
There we go. So I'm good. Hi. How you doing? I'm George Crump. So I'm going to go quickly through some things we do at Storage Switzerland and talk a little bit about Flash. Flash is interesting for a lot of people. But what we're seeing is a real maturing in the request on information. It's evolved from sort of this performance question, while that's still important, but we're getting a lot of concern and interest around reliability, security, durability. So we're going to kind of dive into that a little bit in this presentation. So, who's Storage Switzerland? We're an analyst firm. We cover this space, storage, cloud, and virtualization. So very focused on it, pretty much live and breathe this space. Myself, I have almost 30 years of experience in the storage industry, so I know a little bit more than Greg maybe on a good day. I can remember being in college and running up and jamming punch cards into mainframe, which has done that, and dropping on the way in. Done that? There we go. Everybody's got one of those, right? So we do a lot of work with suppliers, we do a lot of work with end users. We're certainly, accessible if you want to talk about anything, not necessarily just Flash related. And you can find most of our product in what we do on storage-switzerland.com. The reason it's not storageswitzerland.com is I'm also cheap. I'm, by the way, staying at the Campbell Inn tonight. It's $120 a night. I'm a Marriott guy normally, but I just refuse to pay $379 a night for a quarter. So this is me, the way I go. I also give the guys at the rental car counter a hack for charging me almost 30% in taxes. Like there's this one fee on this at the San Jose airport called a convenience fee. What's convenient about that? I would conveniently not like to have to pay it. So anyways, so that's kind of what we do as some background. By the way, keep it interactive. I can handle most questions. If I don't know the answer, I'll just make something up. So I always get asked, okay, what does an industry analyst do? I honestly stole this slide from somebody. I don't even remember who I stole it from. It was so long ago, but it kind of worked. So most of my friends think I just spend most of the time fishing, which is funny because I don't fish. I have a chocolate lab who, if you ever had a Labrador, they just exist to chase tennis balls. That's what I do most of the time. My mom thinks I'm Captain Picard. You can see the resemblance. Most people, I think when I talk to users, they just kind of think I throw stuff around and see what happens. That's probably a little bit true. We like to vendors think that that's what I do, that that's what my lab looks like. We've got a couple of tests coming up that there's no way we're going to be able to do that in our lab. So anyway, so it gives you a little bit of an idea. We spend a lot of time, like I said, focusing in space. So let's talk about Flash. We were sort of on the front end of Flash adoption in the enterprise, mostly, frankly, by luck. But in the early days, if you will, of Flash, when we started moving into data centers and things like that, there was a lot of convincing about why would you get this, Do I really need that much performance? And that was really the big thing. I think everybody looked at it as a high performance option, but it was, do I need that much performance? We no longer have to convince people that they need that much performance. Now, I will tell you that I question some of the 3 million IOP benchmarks that are coming out. I mean, you know, I don't need to play my Xbox game that fast. So the challenge as we hit those benchmarks, and by the way, they're important, is that we have to translate it to a guy that only needs 200,000 IOPS, and why those numbers are important. Right? So that's something I don't think we do. But in general, I don't think we have to do a lot of convincing that you need this level of performance. If you're doing any kind of virtualization, VDI, database operations, things like that, people get it. But reliability and endurance remain unbelievably high as far as a concern for users. And frankly, it also remains a pretty high concern for what I would describe as legacy vendors. If you look at the 3-letter acronym-based companies, good job. They all start with SLC memory first, right? And that's sort of a default knee-jerk, I don't trust flash either sort of an approach. And I don't know if I think we're well beyond that. The second thing that's starting to come up, which I'm really kind of interested in, is that the security issues related to flash and disposal of flash are becoming an issue, which is really good. I'm glad we're getting those questions. And then finally, not a part of this presentation, but I always like to stab vendors anytime I can. They're generally very ineffective at communicating what performance numbers mean. Okay? My simplest example of this is, as a joke, it was a serious article, but as a joke, I had one of my colleagues write an article called "What Are IOPS?" It is the number 5 searched article on our website. So when a vendor comes to me and says, "Hey, we just came out with a thing that does 1 million IOPS," I go, "Well, see, you got a problem," because they don't even know what 1 is, let alone 1 million. So, I think as an industry, we need to get better at communicating exactly why, and I don't know if IOPS is necessarily the best way to get it. So let's talk about endurance. The endurance remains a big concern, like I said, for users and legacy vendors. And endurance is different than reliability, right? At least in my opinion. Reliability is it broke prematurely. Endurance is it sort of burned out. Right? I mean, I think everybody knows that flash will eventually burn out. Okay. Anybody have a hard drive that's older than 5 years in their data center? Yeah? Okay. How about 10? 10-year-old hard drive? Would probably be about this big, right? So, to some extent, frankly, my point there is that I think some of the endurance concerns about flash, if I can get you 5 years out of flash, you're probably going to be pretty happy, right? If I can get to 10, you're good, right? So, some of the endurance concerns I think are a little overstated, but absolutely flash wears out. It's a right condition. I won't go through that with you in detail. It gets worse as we go from SLC to MLC. MLC is the more cost-effective delivery in the startup community, certainly, and everybody but sort of the legacy vendors. It's pretty much a de facto standard now as how we deliver flash capacity. Okay, it hits the right price point. What you also noticed, or what you may notice missing from that list, is EMLC, which EMLC is essentially slowed down MLC so it doesn't break as fast. Right? So what hurts flash is essentially the speed at which you write at it. So that also is sort of off the radar screen as well. So the key is for vendors is how can I get 5 to 10 years of life out of an MLC-based system, right? And the great news is it'll just get worse. I mean, every other technology kind of gets better. Flash is just going to get worse, and for these guys, it's going to get harder and harder for them to get you that 5 years as we change the lithography size. the price points get better, but the durability gets worse. Right? So these guys have to get better at controller functions and things like that. So how do we do that? So there's a couple things. So I like when that happens. So the first thing that is fairly common in enterprise class systems is that we'll do something called over provisioning, which I'm not wild about the word because it kind of confuses me. But essentially, what we're going to do is hide a section of flash so that the operating system or whatever's writing to that flash doesn't see it. Okay? And then what that allows me to do is write more often across more cells, but not expose those to the system. So it kind of gives me sort of a reserve, if you will, that's always being used, right? What is my concern with this is that you are setting aside, so let's say you bought a drive that reports to be 200 gigs. There probably is somewhere, there might be as much as 256 gigs in the drive, right? Well, they're not giving you the 56 gigs for free, right? You're still paying for it. So it drives up the cost of the flash itself. And so you got to be careful with over provision, if I can use that as a term, right? You don't want to use over provisioning in place of good flash management, right? So there's a balance. I think a good question to ask a vendor is how much do they, how much of an allocation do they set aside for over provisioning? That probably gives you a good clue to how good the next thing I'm talking about is their flash controller function is. Okay? So I think it's a great question. If you hear a number that's 30% or something, you might want to ask why. The next thing though is so every flash device has a controller. That controller controls how things, among other things, controls things how things are written to the NAND module itself. Okay? The controller vendors, the guys that make the controllers, are getting better and better at manipulating how that data is being written. Okay? So as they get better at that, they are able to, for lack of a better word, soften or write under high load conditions, as an example, so that you don't hit the memory with its hard to charge, and therefore you end up prolonging the life of the flash. Right? So it allows for a much longer life expectancy of the current technology. Right? And this is probably the key component, and it's very important that you understand who makes the controller. Brian had a good point about the SandForce stuff, right? We see a lot of enterprise flash, we see a lot of flash show up in the enterprise that isn't really enterprise class controllers, right? And so part of the problem where we get the kind of the bad reputation for flash is that we're seeing consumer grade intelligence, if you will, show up in the enterprise, right? So it's a big problem. The other thing is that I don't have a bullet for, so this is sort of free. The other thing is, as we move to devices that are either all flash or let's say heavy flash, you should see a greater increase in life as well. The challenge that you have with a hybrid system, well, there's a number of challenges you can have with a hybrid system, which would be a mix of disk and flash. The biggest is what I would call a turnover rate, right? So the way a cache works, right, is hot data goes up into the memory, and then when it gets old, it comes down, and then other memory goes up. And vendors will tell you, well, that's a read-only cache, but yes, you have the right data to get it there. And you're turning that over too quickly, you're going to go through cycles much quicker. In an all-flash, or let's say a heavy flash hybrid system, you're not going to turn data over as frequently, so you're just going to do less writes. Okay, so keep that in mind. The other thing is DRAM buffers. So when data comes in, DRAM is used for a couple reasons. Brian hit on one of them with the mapping tables, which I'll get to in a second. But essentially, data is put in DRAM and then written to the flash, right? It's not necessarily queued there, but let's say you're going to write a, typically you write about 32K of data to the flash device at any given time. Well, if you send in 40K of data and then there's a pause, I got to do something with that extra 8K. If I decide I'm not going to risk anything, I'm going to put it right to the flash, I burn 8K. I burn 28K of memory, right? And that, in a premium priced device, is a risky thing to do, right? So what most vendors will do is they will hold the write in a DRAM buffer until they have enough data to go ahead and write again, right? And then so there's a trigger that allows that to happen. And you could see DRAM increasing further to allow for very heavy coalescing of these writes, where you just wait a long time, make sure that this is the final version of that particular data set, and then, so that's kind of where we see that going. But this DRAM becomes an important part when we start really talking about some of the reliability issues, which is actually where we'll go next. We have 2 articles on our site, and right now, I'm shocked at it because I didn't think they would do that well. One is on problems with power failures and data loss on the flash, and the other is a problem with power failures and mapping tables, and I'm going to talk about both of those. So flash expects that has this RAM buffer. Everybody knows what happens to RAM if you suddenly remove power from it, right? Awesome. Man, you guys are just on fire. I'm the one that didn't have a monster, okay? Just saying. Tony drank my monster. Can you believe that? I offered. So the problem that you have when you remove power from one of these systems in an inappropriate way is you have to be prepared to do something with that extra set of memory that's in the buffer, right? Now, in a smaller system, that's not that big of a deal. We can have a capacitor, so the capacitor works, and we can dump it to flash, right? One of the challenges that we see, so there's a study, and if you really want it, I can look up exactly the pointer to it, but there was a study done where they basically tested 15 or so SSDs and kept removing power from them. Right? They did it 150 times. Now, I got to tell you, if I lived in a data center where I lost power 150 times right in a row, I'd probably be looking at something else. But, it is a fair sort of thing to think about. And a large majority of these drives either lost data or just failed completely. Okay? If it's a database environment, that's a really big problem. Because you go from 1 million IOPS to 0 really fast in flash environments. So that's really a key problem. And so one of the things that we're now talking to vendors about is what are you doing to make sure that will work? Right? Yes, capacitors are great, but they fail. Are you testing the capacitor? It's amazing how many vendors don't test the capacitor. Yes?
So which of the vendors right now can't handle this without failures?
Say that one for the end. I know I said today I would take questions, but I want to be near the door as I answer.
But also, George, I think you talk about the 15 SSD drives, they're not arrays.
They were standalone drives, absolutely.
Yes.
But think about that, right? So I have these standalone drives, let's say each one of them had an 8K chunk of data, and I lost power from them.
Yeah,
But the RAM buffer isn't redundant.
Yeah, what I'm trying to say is traditional storage system, they either have battery backup or they have some other kind of power that allows you to basically push the data.
Exactly, right. And here, one of the challenges you have in a RAID array, if it's a RAID of flash, see, RAID isn't enough either, because in a RAID of flash, I've still got these independent pieces of RAM that aren't rated. They're not rating the RAM buffer across the individual SSD drives, right? So that's a problem too. So the key thing is to make sure that they're looking at the quality of the capacitor to make sure that it'll do what it's supposed to do when you, for some reason, remove power 150 times. And then if they have a battery backup, same thing, make sure you're testing the battery. That's a very fair question to ask anybody you're talking to. What are you doing at this point, right? Because I've seen, has anybody ever had a UPS fail? The battery didn't work. I happens all the time. I myself, I must buy the worst battery on the planet. They always do. So I talked about kind of what DRAM is doing in the appliance in the first place. The other problem that is probably less known, so now we have boxes that are in the 44 terabyte range, ballpark, 44 terabytes. Pick that number out of thin air. The other challenge that you have as we get to these very high capacity solid state appliances is the mapping table, that translation table that Brian talked about, becomes really big, right? Bigger than the typical capacitor can maintain a charge of that much RAM to be able to flush it to flash, right? Because you're talking a fairly long operation. Now the good news is if you lose the mapping table, you haven't lost data. Okay? It was great to have you go first, but I'm going to use you. So in those customers that were doing hundreds of thousands of transactions, being down for like having your database down for some reason for like, I don't know, 4 hours, that would not be a popular thing.
It's never happened.
Well, if their device went down.
No, that's why we have redundancy.
Oh, yeah. Okay, you're out.
Never
So if this fails, and you don't have a database that has redundancy, and you haven't thought this all the way through, a power failure means you have to do a rebuild of the appliance, right? So whatever you think of, whatever operating system you think in to do a file system scan, that's essentially what we're talking about, to rebuild. Sort of like rebuilding the IO table, right? It clearly is faster because it is a flash device, that's good news. But it's still going to take time. And typically these are going into environments where uptime is very, very important. So that is a key thing. Now what we see, this is kind of an interesting challenge for these appliance vendors, right? Because density drives down price, right? But you create this kind of a big problem. The typical reaction we've seen thus far is that the appliance has to, the appliance vendor requires a UPS. I'm good with that. Except most appliance vendors don't do any integration work to the UPS because UPS batteries, you guys are awesome. Yes, they fail. And so if you require a UPS and it doesn't work, what do you have? Nothing. No. And again, zero IOPS is really slow. So that's the real issue there. So again, another question to ask vendors is, what do you do to protect them about that? Right? Are you integrating? If you're going to require a battery, what are you going to do to integrate to it? Right? Now the good news is there's other ways to do this. Right? There is non-volatile memory technology that you could integrate here. Okay. This becomes a challenge for companies that are using, let's say, more off-the-shelf componentry, right, where there's a lack of integration, right? Because now you're trying to take somebody else's SSDs, probably somebody else's battery, some non-volatile memory technologies, about 3 or 4 out there, and get it all to work, right? And now you don't have that sort of off-the-shelfness anymore. And so that's where this sort of integrated concept really becomes very, very important. Does all that make sense for you? Yes?
It seems to me that the testing is not something you do once. It's something you have to do on a continuous basis. The battery capacitors could fail at any one time.
Absolutely. Yeah. Yeah, like all the time. Like all the time. Absolutely. That was an example of a good question in case anyone wanted to, anything that sets up a key point that's really good. All right. Any other questions on that? And I put the picture of the power supply there because that's all I had. something broke, right? So it wasn't necessarily the power got moved or something like that. So in these appliance type systems, we're seeing generally a common move toward a couple things. Number one, RAID, right? And a thing to look for there is specific support for flash. Again, we're talking about a technology that doesn't like to be written to, right? So the less times we write to it, the better. So a RAID that's optimized for that sort of environment is pretty important. Secondly, we're seeing the capability to do what I call an in-place chip fail. So you can have parts of the array just die, or parts of the NAND itself die, block those out. That, by the way, is very important here in a minute. So we can block out parts of the chip, so we keep using the rest of the NAND for ourselves, right? So we don't have to replace the whole thing. And then, of course, we're seeing a good effort, especially from the startup community, in addressing sort of redundant components, right? Where you don't have to buy, a whole bunch of extra gear. So, like I said, the bigger problem, kind of backing up, is dealing with the power fail type of situation, right? And again, I know that most data centers have some sort of backup power in themselves, plus a UPS. But again, you're talking a fairly risky situation where you generally you invoke flash because you need some sort of performance. It's a mission critical environment. So I get very nervous when the recommendation is just a UPS. I'll be honest with you, I just don't trust UPSs in general. And like I said, in most cases, the appliances don't do a good job of detecting UPS health. Secondly, capacitors are equally risky. Again, I'm not hammering the capacitor industry. If there's any capacitor guys, please don't follow me apart. But they, just like any other component, can fail. And it's really incumbent upon if you're going to use capacitors, it's incumbent on the appliance vendor to address that and make sure that they're constant, like my friend in the back said, check. And then finally, I think NVRAM is eventually the right approach. In fact, now is the right approach. There's good, solid technology on the market. Still, you want to be able to test that, make sure it's reliable, as if you would any other component. But it gives you the speed and everything you want to get the job done. So let's talk about security. This one almost makes sense. Yes. No, you're not asking this question. This is going to be hard.
Humor.
Okay.
So I was talking to a three-letter agency, and they were very convinced that there were bit errors that were undetected coming out of flash devices. How much do you hear about that, and if people are worried about it?
I would say the general mainstream community doesn't worry about it at all. How real is it? I think they're definitely bitter. How real is it, and how much does it impact data? I don't know of a single loss or corruption event associated that could tie back specifically to a bit. So I would say, in my knowledge, I'm not saying it doesn't exist. 3 other government agencies that steal phone records. Maybe that would be the system we wanted to fit.
First, I was talking about the FDA.
Oh, that too. Now you got me totally. Is that your question? Okay. Yeah. Okay. I guess I could just said that. So erasing flash is a little different than erasing a hard disk. If you want to securely erase a hard disk, you essentially format it over and over and over again, right? Fill it with 1s and 0s. Everything's good, right? Or put a hammer. The problem is some of the things we did to fix other problems create a problem when we start talking about security, right? So one of the problems is that over-provisioning hides cells. So if you at an operating system level go to format, it's only going to format the stuff that the operating system's allowed to see. Guess what? The stuff that could be, in the example I used, there could be 56 gigs of data that has not been formatted, that probably has data. Right? Now, part of the question is how badly does the bad guy, guy with a really green helmet there. If you see this guy walking through your data center, first of all, you should probably stop drinking so much at night. But the other challenge is you've got to know that there are certain people now that are going to go get data, right? And there's parts of data that would be very valuable. So like, we see this as a growing risk, not just in three-letter government agencies, but clearly that's a great place to start. And the other challenge is the in-cell replacement that I talked about, right? Where we just mark it, chip bad. There are situations that arise in flash memory where we can no longer charge a cell, right? The way you do everything to memory is you charge it. It's still readable. You just can't write data to it. How do you erase a cell? You write data to it. I can't write data to it. Guess what? The data is still there. It could be detected. In fact, my belief is it's probably easier to get data in that situation than if that's in that situation. So let's talk about that. Erasing flash is basically a false sense of security. I remember typing that slide, I couldn't remember, there was a false something security. I couldn't remember what it was. It's false sense of security. There are special tools that some flash vendors have that will do some of this. What you got to do is be very careful and ask them what they're talking about. Right? For example, will it go get to those hidden areas that are part of the early provision process? It could. I don't know specifically of any vendor that's claiming that it will today. And then probably the biggest thing, how do you erase something that can't be erased? Because I don't know how to do that either. So how do you fix this? If you're in this environment, did you have a question?
The same problem exists with hard drives, though you've got spare sectors. You can no longer use their output, they have data, which you can't read.
Right, I would think that's a fair concern. The challenge with the difference I think with memory is because it is, this is just my opinion, so I don't have any facts about this, but I don't need to let that stop me anyways. But my opinion is that it's easier to get to a piece of flash in a lab than it is a hard drive, as far as hooking up, tapping into it, pulling data from it. Plus, there's a conversation about flash. Yes?
What's wrong with physical destruction? Just shred it to dust. They release the hard drives.
You can do that. It's really hard to sell on eBay afterwards.
Well,
My customers do
but if it
Yeah.
They shred the drives.
Yeah, if you shred it, unless there's somebody that's really talented.
Right, but if it burned, okay, so you're talking about resale now then. Okay.
Or moving into another department. There could be a lot of reasons why you don't necessarily. Because remember, I mean, the guys in Skyera are very much competitive, but it's not free.
Is there any way you can actually reconfigure where things are stored?
What's that?
Is there any way you can actually reconfigure the way things are actually stored? So essentially, it's kind of
Reformatted, right?
Yeah.
Well, you still have the two problems. How do you get to the hidden area caused by over-provision, right? And I think you can do that through a utility, right? That's outside the OS. But the bigger problem is still how you get to these cells. This is it, right? I think eventually they either will or whatever get to have a utility that can wipe all the memory. But if you can't get, the cell will no longer take a charge. It's there. Well, what if the cell has social security number? And so we think that you have to have encryption. If that's a concern for you, and I think increasingly it's going to be a concern for more and more organizations, you've got to have encryption in line all the time. Right? It can't be an encryption you apply at the file system level because the file system doesn't have access to everything. It's got to be done by the device in line as the data is being written. That way, if I have a cell that's chargeless, it's encrypted data anyway, so it's okay. Does that make sense? So, just some ideas. So from an endurance standpoint, there's a lot of things that people are doing to get around endurance problems. I use the word trick, that's probably a little too harsh. They're all very creative and they're important. Over-provisioning is a very effective way to increase flashlight, but it's not enough, and in some cases it could be too much. Right? You don't want to take a premium priced storage device and raise the price yet again because you've got 25% of it hidden. Right? And remember, you know, in the enterprise, we're not talking about a 200 gig drive. We could be talking about a 40 terabyte unit. 25% of 40 terabytes is pretty expensive. Secondly, understand the reliability issues. Again, there's a lot of things you can do to increase reliability, durability, endurance. The move, I think, should be toward non-volatile DRAM. That gets around a lot of the battery issues and capacitor issues. If the vendor's going that route, you need to really investigate how they're talking to the battery and how they're talking to the capacitor. As my friend in the back said, it has to be all the time. You've got to be constantly monitoring. And then finally, be aware of the security risks. If clearly if you're in an environment, yes?
Question, why do you say over-provisioning is not enough, but then you say it's too much? What's not enough about over-provisioning leading to improved endurance?
Okay, so it's not enough because there's other things you can do at the control level as far as manipulating the way writes are written to increase life. And then it's too much because if you just solely rely on over-provisioning as a vendor, you could be allocating, you would have to basically charge 25% more than, say, a competitor would because they don't use much over-provision.
Just by over-provisioning, you can't get the controller to do certain things for 5 years and then to
No, absolutely. Well, I would assume if you over-provisioned enough, you could get that life out of it, but you're not artificially because you're paying for it, you're actually raising the price per gigabyte because you're paying for 25% extra capacity.
the bottom line is the cost angle being, you're going way too much on the cost.
Exactly. And so the right thing is a balanced approach, 10 to 15% over provisioning with intelligent flash controller technology that can manipulate writes is really the key thing. Is there a question? And then finally, like I said, just be aware of the security risks. There's some environments where it just isn't applicable, so it's no big deal. But I think there's an increasing number of environments where security and encryption are going to be key to what we do in the enterprise. So, look for that. I think that what I'm seeing from the security angle is the only logical way to address it is encryption. And I don't know if you guys can see it worse than I can, but there's my contact information, website. We're kind of active on Twitter. We've got a few YouTube videos. Find entertaining. Question? Thanks for your time.
Okay, thank you, George, and thank you all. So, if you have any questions at all for George or for SkyEra or for Aerospike, then you can either ask them in this type of format. Feel free, or hang out for a little while and then pull someone off to the side. So you choose. But if you do, we're here. But thank you all for attending.
All right, thank you.